In this Godot Multiplayer tutorial, I'll teach you how you can move your NPC enemies from the client to the server so that they're all shared among your peers and you can go hunt and kill some enemies together with your party. Let's get started. To communicate all that information we will be generating and tracking of all the enemies on the map, we're going to be making use of the world state. Now, this gives me a good opportunity to point out one line of code that I forgot in the last tutorial. I know, shame on me. In the last tutorial on clock synchronization, we had the render time still as operating system time because I forgot to mention to you that you should change that into the now updated game server client clock. By doing so, we're making sure we're using that clock synchronization in our interpolation and extrapolation functions. If you have followed the tutorial series so far, you've probably noticed, and I mentioned it before, that when one player attacks an enemy, that is not registered for any other players. So if you need 3 shots to kill an enemy and you fire 2 at it with one player, then another player would still have to fire 3 at this entity. Also, if that entity dies, it only dies for the player that actually killed it, and not for all the other players in the game. That's what we're going to be addressing in this tutorial. So I'm right here on the game server, and on the game server I've created this new node map. Map is going to keep track of a variety of elements for us, including the enemies that are on our map. Now, if you have different maps or you have chunks, then you might want to create a singleton for every single map or chunk, or you might want a different kind of architecture. I'll leave that up to you. In this tutorial, our map is super short, so I'm only going to be needing one node. We have a couple of variables on the top to start it off with. First, we have the enemy ID counter, which is basically an integer that's going to add +1 every time that a new spawn is come in, and that number is going to be, or that integer is going to be our enemy ID, so we can keep track of it. The enemy maximum is the maximum amount of enemies that is allowed to spawn on this map. The enemy types is the type of enemies that are allowed to spawn on this map. Currently, I only got one entry. I did implement some RNG function here, but that's always going to draw the same wherebear brown. But I could add several other types to this list, and if I do that, I would also have random enemies spawning. All I would have to do on the client is to make sure that I add the right sprite sheet to that kinematic bodies sprite so that you actually have the right rendering of that specific type of enemy. We're not going to get into that now because that's not what this tutorial is about. Then we have the enemy spawn points, which are 3 vector 2s with possible locations where an enemy could spawn. Then we have the open locations, or basically the unoccupied locations. These are index references to this array. So that means that currently, as the server loads, all locations are open because of course we didn't spawn any enemy yet. But as enemies are going to spawn, we're going to take these numbers, these index references to this array out of here and put them into the occupied locations dictionary with the enemy ID, so we can keep track of which enemy was spawned where, so that when we kill an enemy, we can bring that spawn location back into the open locations so we can redraw from those locations in our random spawn function. Then lastly, we have the enemy list, which is basically keeping track of all the enemies that are spawned and their stats. Then, to get it started, on ready, so when the server starts, we create a new timer with a wait time of 3 seconds. It auto starts, and every time it times out, we're going to spawn an enemy. Of course, if certain conditions are met. Lastly, we add that timer to the tree. On that timeout, spawn enemy, we're first going to check if the enemy list, so that's that dictionary, if that size of that dictionary is equal to or bigger than the enemy maximum, which would then of course mean that we don't want any enemies to spawn, so we pass. Otherwise, we do need to spawn some enemies, and we first randomize the seed to ensure we get some random numbers. We're first going to randomize the type, which of course in this case wouldn't work because we only got one type, but in case you want to add some more enemies, here you go. And we're going to determine the random number generator location index for all of these 3 variables, the enemy spawn points, open location, and occupied locations. First, what we do once we have that RNG location index is we determine the location where this enemy is going to spawn. So we're going to take the enemy spawn points, that's all those vector 2s. Then we're going to take the open locations and the random number generator. Then, once we have determined that location, we can move that location into the occupied locations. So we're going to say occupied locations, then we're going to use the enemy ID number because we need to keep track of which enemy is in which location. So that once an enemy dies, we can give that specific location back to the open locations. And we're going to basically use the same reference as we used right there to determine the location, put that into the occupied locations. Now, of course, that also means that we have to remove that location from the open locations because we don't want to redraw that number again once the next enemy needs to start spawning in. Okay, so now we pretty much have all the information we need. Now we can add a new entry to the enemy list. We're going to use that enemy ID counter to give that enemy a specific ID. Once we have done this, we add 1 to the enemy ID counter so that number is never used again. Then the enemy type is going to be the type we determined on there. The enemy location is going to be this location. The enemy health I've set to 500, both the health and the maximum health. We need both numbers in case this enemy ever needs to heal up. And also we need both numbers to calculate the percentage of HP so we can properly display that in an HP bar. Of course, you can put a database behind this and extract that health data out of a database to make sure that with the right type you match the right amount of HP. All possible, leave it up to you. And currently we don't even have anything according to attack or defense or anything like that because our werebears cannot fight back. Not part of this tutorial. This is all about just giving you one example how you can do this. Then we have the enemy state, which is going to be idle, and we have a timeout. Now that timeout is important because that's basically what helps us respawn enemies once they have died. We do that pretty much in the next couple of lines right here, because once it has spawned an enemy in, we're going to use that same timer, that same 3 seconds, to also check for every enemy that has already been spawned. If that enemy state is dead, now how we kill them we'll get into later in this tutorial. That's this function right here, NPC hit, but let's do one thing at the same time. If that enemy is dead and also the timeout is 0, then we erase that enemy from the enemy list. By erasing it from the enemy list, then this if function then of course allows for new enemies to start spawning in because the enemy list size is then reduced by 1 and then obviously we're going to spawn some things in. If however that timeout which we set at the start at, what is it, 1 is not 0, then we're going to deduct 1 from that timeout. So basically right now if I kill an enemy, it's going to take 6 seconds. The first 3 seconds to get that initial 1 to 0 and another 3 seconds to then erase it from the enemy list before the next enemy spawns in. Now, 6 seconds is really short, but I of course do that for demonstration purposes to you. So all of this data, now we have basically the enemy list right here. That is where all this data is collected and which is always going to be, let's say, the truth on the server that all the peers need to be aware of. So to do that, on our state processing script, where we generate the world state, every time that the world state is being sent to all the peers, all the players, we're going to add a new key to this world state dictionary that is going to be enemies, and for that we're going to get that enemy list out of that map node. Now with that, we're sending off all this information to all the peers, all the players in the network, and we can start writing some code on the client side to make sure that this data is extracted and that actual enemies are being spawned, and then we can start working on killing them. I'm on the client side now. I'm on the map script, the script that we used before to process our world state into interpolation and extrapolation so we can see other players move around. We're going to be expanding this code to include the enemy data that we've just communicated in our world state from the server. So within our physics process function where we are doing the interpolation extrapolation, the first thing we have to do is we have to exclude that key, that new key in the world state dictionary, enemies, that is not misinterpreted as another player. So we have to include this extra exception. I've put it here in extra lines. This is new in this tutorial, so I can remove these lines now for you. So once we've got that exclusion, we make sure that the player interpolation stays working. And of course, we have to do exactly the same on the extrapolation part. So also here we have the if string player enemies, then continue. So now that we got that, as you can see, here we're iterating over every player in that world state as we coded in previous tutorial. And now, new in this tutorial, we are also going to be iterating over every enemy in world state buffer enemies. Now, it might be a good idea, I haven't changed that myself yet because I didn't want to confuse you, but it might be a good idea to also include all the players into a separate sub-dictionary within the world state, just like we now have all the enemies in a sub-dictionary. That might make that you can delete some of these exclusions, as probably you would otherwise have to add on top of these exclusions more and more with resource nodes and all kinds of other stuff. So, might be a good idea to optimize the code there a little bit. I'll leave it up to you, it should be pretty easy. So for all the enemies, that's where we are. That's what's important right now. First of all, we're going to simply say that if not world state buffer enemies has enemy 1, then we continue. That's pretty much exactly the same line of code we have right here for the players. That's basically saying like, okay, if you found this enemy in this world state, but that enemy is not present in the previous world state that I received like 50 milliseconds ago, then don't do anything with it, because we don't have 2 locations to interpolate between. Then once that is not the case, we're going to check if that enemy already exists within a node tree. And if that's the case, we're going to determine the new position by lerping that location of the previous world state and the future world state with the interpolation factor. Exactly the same like on the player. Of course, this is not really going to do anything for us, because right now our enemies are always standing still. But as soon as you give them movement, this code is going to work for you. It's going to interpolate all those enemies and they'll all be moving around on the map super smooth. So another line of code that we got right here is health. And that is something which is new. So on health right here, we are going to be communicating that to the node constantly on every world frame. So in many cases that health might be exactly the same as the previous world frame, but as soon as it changes, we can start updating the HP bar. I'll show you that in a moment, but that's an extra line of code we don't have on the player. That of course would be something if you're using this code to create a PvP experience. You would add this health on top of the code right here for the players to make sure that the health bars of other players are updated, if you want health bars to show for other players, of course. Now, with all of that said, if this is not the case that that enemy already exists within a node tree, then we're going to be spawning that enemy in. And we're going to add the enemy, so that will be the actual index number of that enemy, the enemy ID I should say, and the world state buffer to enemies enemy. We're going to push that to this function so that it has all the information it needs to properly display this enemy on the map. This spawn new enemy function is on the top right here, so it's going to receive that enemy ID and that enemy dictionary. We create a new enemy, which is going to be an instance of enemy spawn. Enemy spawn is just like a player spawn, is a preloaded scene. Of this case, this werebear. You might want to put a sort of general enemy in there that you can add things to based on the type that it is. I'll leave that up to you. I just need this werebear for now, as this is just a tutorial to demonstrate to you the multiplayer framework and not specifically how to, in the most elaborate way spawn enemies in your multiplayer games. So once we got that instance, we're going to set its position by the enemy dictionary, enemy location, its maximum and current HP by their respective values, the type, the state, and we are going to rename that node to that enemy ID, so that whenever we kill or attack or do something, we can use the node name to communicate the right enemy ID back to the server, so that the server knows which enemy was attacked or needs to do other things. Then we're going to get the node Y-sort enemies and we're going to add that child. So that is going to be, when you look at the map, we of course have the Y-sort, we have already the other players that we use, and just like other players we also have enemies. That enemies used to have 1 or 2 werebears, I believe 1 werebear. I already deleted the werebear out of here that used to be on the player side. That any werebear used to be there. If you want to be 100% sure, I'll hide it for now. You can see that werebear that used to be here in the corner, it's gone, it's not there anymore. So now we are basically spawning in new enemies, new werebears. All we got to make sure is that whenever we hit a werebear with an ice spear, it needs to start dying. So let's have a look at the werebear. Let's see on the new code there. There's quite a bit of code also for the HP bars that we added. And then I think we are ready for a test, and you can code all of this in your own game. Right, so that werebear. Let me look him up. Oh, I got him right here. So first of all, I've added an HP bar, a rather big HP bar, I might say, to the werebear, so we can keep track of what's happening with these werebears, and you can see on 2 different clients that the HP is actually updating. So for health bars, like you can pause the code if you want to on the HP bar code. I'm not gonna go over it because I've got one specific tutorial all on HP bars as part of the combat series, like an 11-part series on all kinds of combat mechanics, from AoE spells to Nova spells and all kinds of other stuff. So I would suggest you watch that tutorial. I'll link it up on the top, and then you can get all in this HP bar stuff. This HP bar is made exactly the same way, including the tween and everything, as that tutorial. So that should set you up properly. Now let's have a look at the code of the werebear. We used to have previously, whenever the player hits the werebear, we had it on hit, we communicated the damage, and we were basically going to be reducing the damage from the current HP, and we played on death whenever that werebear had 0 HP left. Now, of course, this function created that the werebear would only die locally for that one player and not for the other players, because of course this current HP is a variable on this local client, and we need to deduct the HP on the server so that the server can communicate the new HP back to all the players, so all the players see this update. So we are going to be retiring this little piece of code, and we're going to be substituting it for a game server interface call. So that's going to be a call to the server interface, the singleton. We're going to call NPC hit. We are going to get the integer of the name of this node. Remember, that's going to be the enemy ID, as we set the enemy ID as the node name. And then, of course, we're going to be communicating the damage. Now, there's a big if here. This code is exploit sensitive because all the physics are still being simulated on the client. That also means the collision detection is done by the client, and you could write an aimbot for this game. Also, the damage value is being communicated by the client. That damage value could be intercepted, increased by an absurd number, and suddenly a player is walking around with God mode. So this is going to be an intermediate stage of where we're going to go to in this tutorial series. I can't smack everything into one tutorial because it will become 1.5 hours long. So this is just going to be intermediate, and on the next couple of tutorials we'll also move the physics simulation from the client to the server, and also make sure that the client is not in between anymore when it comes to the damage value. So for now, we'll just leave it at this. We'll continue with the code, and we'll add on top of this in the next 2 or 3 tutorials. Right, so now let's follow this NPC hit function to the server and back so we can see how the server processes the health, and then we'll have a look at these last 4 functions and how they interact with the werebear to make sure that we render the right data at the right time for every single player, whether they're already in the game or just logging in. So the NPC hit is going to go to the game server interface. So the game server interface has that function NPC hit, calls the server, send NPC hit with the enemy ID and damage. Switching to the game server, on the game server interface, we have that remote function send NPC hit. We get the node map and we run that NPC hit function that you have seen earlier underneath the spawn enemy function. So I've opened up this function. Let's have a look at it. We first filter if this enemy does not already has its HP reduced to 0 or less. That looks like a little bit of a weird line of code at the start of this function, but it's crucial. Let me explain by first explaining the rest, and then it will start making sense. First thing we do is we subtract the damage we've done to this enemy from the enemy health, and we save that as the new value for enemy health. Then we check if that enemy health has reached 0 or less, in which case we are, oh, I got 2 prints here, don't need those. In which case we set the enemy state to dead. By communicating that to all the peers, we can play the right animation. Then under the open locations, we are going to be appending the spot that this enemy was occupying. So of course, as this enemy is dead, we now want new spawns to be able to spawn in that location. Then finally, we don't want that location to be present in both the open locations and the occupied locations at the same time, of course. So we're going to erase the enemy ID from the occupied locations. Thereby, we're totally freeing up that spot. So why are we filtering for this, you might ask? Well, the server knows that this enemy is dead before the clients know it. The moment that this enemy dies on the server and we set this enemy state to dead, only once the client has received this dead state, we can turn off the coalition shape of the enemy on the client side. And until we do, that client can still hit the enemy. For the client side, that HP bar is not to 0 yet on the enemy, and the spears and the AK-47 bullets and the lightsabers and the swords are still hitting it. That means that on all those hits, the clients are still going to be sending in those this NPC hit functions. That means that once we have erased this enemy ID from the dictionary and we get another hit in there because the clients are buffered 100 milliseconds in the past and they don't know that enemy is dead, we are going to get new NPC hits. And if we wouldn't filter for the fact that enemy health has already been reduced to 0 or less, then we would try to re-erase that enemy ID from the occupied locations, but that occupied locations doesn't have that ID anymore. So you get an error that the key was not found in the dictionary. So because of that reason, because of that buffering of the world state on the client side, and because the server knows that the enemy is dead a little bit earlier than the clients know, we need to filter for that enemy health the moment that this function starts, that we don't throw any weird errors. Okay, so now we got updated health on all these enemies, so what now? Well, on the server, we actually don't have to do anything, because this enemy health is being updated in the enemy list, that enemy list being the main dictionary that holds all the data, and in state processing, on the next state, within 50 milliseconds, we're going to be sending that enemy list from the map node in the world state to all the peers. So we're sending that new health everywhere. So all we got to do is make sure that the client is processing all this data. So going back to the client, and let's first start by going back to the map where we were doing that interpolation of our enemies. I've already explained to you that we have an extra function call here for health. And every time that this world state comes in, we're going to be pushing that health to that enemy. So if soon as this health is being updated by the server, the next time that the client receives a packet, which is within 50 milliseconds, we're going to be updating, or at least we have to be updating that health in the function on the werebear. So let's move to the werebear, and let's start when we actually spawn this werebear in. So we have to, go back a little bit because, well, it makes sense to explain to you now why things are going to be happening the way they are happening here. So the moment that a werebear spawns in, the player has received a world state with a new werebear, a new enemy in there, and spawns it into the map. At that point, the spawn in function already sets our maximum HP, current HP, the state, and the type. Under the ready function, we are now going to set a couple of things. We're going to set the HP bar value to the percentage of HP, which is the current HP divided by the maximum HP multiplied by 100. If the state is idle, we're going to play the idle southwest animation. And if the state is dead, then we're going to stop the animation player. We set the sprite frame to 219, which in my case is a dead werebear sprite. We're going to set deferred disable the coalition polygon 2D, so we cannot bump into the enemy anymore. We're going to do the same with the hitbox, so we cannot hit it anymore. And then we're going to hide the health bar. And now you might be wondering, and that's why I've explaining this to you now, why in name are we doing under the ready function things other than let's set the health bar to 100 and let's set the state to idle and play animation play southwest? Well, here's the catch. This is a multiplayer game, duh. But it could be that when a player is logging in, that at that point another player is already attacking an enemy, making that enemy's HP bar not being 100. And it could also be that another player has just killed a werebear within the 6 seconds before that player logged in. In that case, we've got a dead werebear on the map, and we need to display that werebear as a dead werebear because, will be cool, we can actually see those. So that's why, even though this happens under the ready function when a werebear is just spawned in, we're still allowing that werebear to be dead or to be partially dead, as that can be the case as by the actions of another player just before you logged in. So now that we have got that, the move function is pretty easy. That's the same move function as we have on other players, and that's pretty much what's part of the standard interpolation function here, move enemy, where we also had here move player. So that's nothing special. We also have health. Now that health is that extra function that we had right here, so that's where we actually have to change health. We got that function health right here that checks if the health that we received out of the world state is different than the currently known HP of this enemy. If that's the case, then we set the current HP as the health that we received. We run the function health bar update, and if that current HP is equal or lower than 0, we run the onDev function. The onDev function does nothing really special. You already seen most of this. It turns off the collision shape so that we can bump into the enemy or still hit it with our lightsabers and AK-47s and ice spears and fireballs. We run the animation player play dev southwest. That is different than when we set sprite to set frame 219. Because as a player logs in, we want dead enemies to just be a body on the ground and not play their death animation the moment you log in. That would be a little bit weird. But of course, if a player is killing an enemy, or if the player is in a vicinity of another player killing an enemy, then of course we want to play the proper animations for that. We hide the health bar, so don't clutter the screen. And the Z index -1 is very specific to my game and my tile map, and this little bit of a demo. You probably don't need that, so probably ignore that. Then the last thing we have is a health bar update. This is all part of the tutorial I mentioned about health bars, so I'm not going to go into that. Pause right now if you need it. All right, with that we have pretty much an entire function, so I guess it's time for a test and demonstrate to you how this works. So I got two clients here. I'm first going to log in with one client, and once we've got that client logged in, we're going to kill a werebear with this guy, and then I'm quickly going to log in with this client here and see if it all updates properly. So let's kill this one. We quickly log in with this one. You see a dead werebear appear and one alive one. Of course, the code in the meantime running, and soon we'll have a new werebear spawning. There we have a new werebear. And if I hit this one, you can see both clients are updating their health bars of that particular enemy. And if I were to switch to this one and kill this one, or hit it and kill it, it dies on both of the clients. Now, as you probably noticed, you can't see the ice spears of one and the other players, because the ice spears are still being generated and rendered, and they live on the client side. So that's up in the next tutorials, is moving that ice spear to the client, or sorry, to the server, and then also doing the physics coalition simulation on the server, so that everything is done by the server and the players cannot exploit in any way anymore. With that said, let's kill some werebears, and that's it for today. That was it for today, guys. Hope you like it. If you did, smash that like button, hit subscribe. Don't forget that little bell icon to make sure that you don't miss out on the next tutorial in this multiplayer series. Now, it's the 28th of December today, so I'm going to wish you all a very happy and especially healthy 2021. 2020 was a weird year for all the obvious reasons. Weird both because there's a positives and negatives. On the positive side, the community of the Game Development Center has grown exponentially, and for that I'm super thankful to all of you. Let's try and see if we can make 2021 an even better year, with even more growth, that we have even more people in our community that can learn together and learn from each other and share experiences. So if you want to contribute to that growth, and if you want to give me a little bit of a late year holiday present, pick your favorite tutorial series, whether it's the combat series, the movement series, the animation series, or this multiplayer series, and post it on your favorite forum. You know, let other people know that this channel exists, that in your opinion, hopefully, it's making good content and that you can learn something here. And if all of us, you know, make a shout out to this channel, I'm sure we can grow the channel even so much faster than we already do. And that's going to benefit everybody. So if you're with me on that, I thank you in advance, and I hope to see you in the new year. And until then, keep on gaming, keep on coding. See you later, guys.